so the question is, you know, uh, as far as it goes, if you haven't done a whole lot, that's fine. I'm just going to kind of introduce a little bit of this. I mean, we were doing Venn diagramming, and so sort of we're going to kind of shift gears now and move into like what's kind of like truth tables, but some of the translations we'll also use with like what we use like with traditional or sentential logic, and we'll basically translate statements into symbols like letters and little symbols, and then we use that information to do either what we call truth tables, or we actually follow the logic step by step. And so the first thing with this unit, it's only like a week long, this module, is all about how to translate those statements. Does that make sense?
Yeah.
And so, as far as it goes, it's a little bit different in that, before, like, if you had a statement like, all dogs are canines, you'd kind of be looking at it as like, here's the subject, here's the predicate, we'll make that D, we'll make that C, that kind of thing where we kind of abbreviate each part of it, each noun. Whereas with what we're going to do now is a statement like all dogs are canines is any sentence we take as just a whole statement and we just call it D. And so we take a whole entire thought as a statement is just symbolized with a capital letter. Okay? And then we can then show the relationship of the sentence as a whole to each other through a series of basically 5 symbols. You have the letters. A letter is just a sentence or a statement. And then we use a series of symbols, and those symbols are, I kind of have to write in this one spot. If anybody's actually going to watch this, I don't know. But we use these symbols like we have bar, which is just like a minus sign, and that is just called bar. And what bar does is bar basically says not. It's basically saying the same thing as not or no. And so if you have a sentence like Joe is here. Okay, Joe is here. All right, there's a statement. We would symbolize that as one thought as just the letter J. But then, in order to show like some relationship, anytime you negate that, instead of making a negated thought like Joe is not here, J, we want to be able to say that there's a not in there. So instead that we would change like Joe is here is J, and then we would add a bar to say that's not true. Okay? That's all a bar does. And a bar can be put in front of individual letters, but it can also be put in front of a group of statements. Okay? Then what happens is we have our next symbol, and our next symbol is the plus sign. And some logic books use what they call dot. And all the plus means is it just translates the idea of, this translates the idea of not, this translates the idea of and. And for as far as that goes, I think how I want to say this. As far as the word and goes, any word like but also means and. So I say like Kirsten, right? Kirsten is here, but she has to leave early. Then, and I don't know if that's true, but I mean, suppose I say that Kirsten's here, but she has to leave early. Or Kirsten's here, but so is Chloe. Those mean the same thing as Kirsten is here and Chloe is here. But in an ordinary language sense, means something a little bit additional, which means it wasn't expected. But it really means the same thing as and. You can substitute the word and anytime you have the word but, and it means the same thing. And so, for example, if you have a statement like Kirsten, is it with a K?
Yep.
Is here, and Chloe is here, then we can just say Kirsten is here is one thought, that's K. Chloe is here, that's C. But then this is just a statement, this is just a statement. We need to show Both of them are true. So we just put a plus between them to say this is true and this is true. Now the question becomes, you might say, well, what's the whole point in symbolizing this? The whole point in symbolizing this is oftentimes you get statements like, I was thinking the other day, you have a political thing, like if Trump was elected, then this will happen or that'll happen, or if Trump the other day said something to the effect of, if abortion was legal or illegal, then he would want to punish women who get abortions, right? I don't know if any of you heard that on the news or anything. And so what happens is people get all hung up in the ideas in there, like this and this and this, And what this does is it allows us to strip out all the language that might get us bogged down in like, well, that's true or that's not true, or Trump's not going to win, or he is going to win, or I can't stomach this idea. And we can actually assess their arguments without all the baggage of the ordinary language. By removing the language, we can focus in on the argument itself, how it's formulated. Does that make sense? And so that's why we do it. So then plus is just a way of saying that and that. And then we have what we call wedge, which looks like a V. And that basically just translates the words or. And so, if Kirsten is here or Chloe is here, then we would just use K or C, and we use the wedge. Then we have two others. One is called horseshoe. Okay? And horseshoe is like a horseshoe. Looks kind of like a horseshoe. And it means if, then. Or it symbolizes the sufficient, necessary, conditional link. Now, what does that mean? All that, you're like, okay, what's that mean? Well, anytime you have a statement like, if it is sunny, sometimes I'll tell my kids something like that. If it's sunny, then we'll go for a walk, okay? To relate this conditional relationship, what you do is the if part is called the antecedent, and the then part is called the consequent. And what we do is whatever is there, like sunny, we put there, we put the horseshoe, and then we go walk, like that. So then this is saying, if S, then W. This is saying this, then that. But it also is saying it's a sufficient, necessary, conditional relationship. If you guys remember, we did sufficient and necessary conditions. I think, was that in the last unit, or was it before that? It seems like maybe we had something on that.
I think it was 2 units.
Okay, it may have been chapter 5 or something, but or module 5 or something, or 4. I'm sorry. But the idea here, if something is sufficient to make something true and necessarily true, like being a dog is a sufficient condition for being a canine. That's enough to make one a canine. But being a canine would be a necessity to being a dog, right? That kind of relationship exists. Well, whatever comes before the horseshoe is always our sufficient condition. Because what happens is, if this is true, A horseshoe B, if this is true, then this part has to be true. So this being true is sufficient to make that part true. Furthermore, if this is true, then this will necessarily be true. This is sufficient to make this true, and this will necessarily be true whenever this is true. So this is always what we call our sufficient conditional, and this is always what we call our necessary conditional. So if you ever have a statement like, blank is a sufficient condition for that, whatever is the sufficient condition goes as the antecedent, as the thing before the horseshoe, and the part after becomes the consequent, the necessary. It's easy to remember this if you use the acronym SUN, or you kind of remember this as the sun. The sun, it's sunny, blah blah blah. Because if you look, SUN. If you turn that U over to make it a horseshoe, sufficient, horseshoe, necessary. Okay, so that's an easy thing to remember. And then the last thing we have is what we call biconditional. And biconditional is symbolized with triple bar. And what triple bar, and sometimes in the book and online, I sometimes just use an equal sign just because it's easier. But it's basically an equal sign with an extra line. And what triple bar means is it symbolizes the idea of if and only if, which is a biconditional relationship. And what that means is if A is true, like if Kirsten is here, then Chloe will be here. But it's also the case that if Chloe is here, then Kirsten will be here, right? So if Kirsten's here, then Chloe will be here. If Chloe's here, then Kirsten will be here. Both of these are basically true statements. It's like basically saying this is true and this statement is true. And so what happens is instead of having to write this whole thing out here, what we can actually do is we can just put K triple bar C, and it means the same thing. It means basically if the antecedent is true, then the consequent is true, and if the consequent in that one is true, then the antecedent in that one is true. And so there's a direct relationship. Okay? Now, what happens is we can use those symbols to translate any ordinary language statement. You can take something as complex as, if John is here or Cindy is here and Bill is here, then it's not the case that Louise will go to the store and Jeff, if and only if it's sunny. Something like that. We could actually translate that into a symbolic statement. What we would do is we would just need to be careful to make sure to add parentheses in between things and bars, and we would have to find what we call a well-formed formula, and we'd have to make sure we get it in that order. Basically, the rule is anytime you have two letters, a bar can go in front of any letter, and it makes it one statement. But anytime you have two statements together, like two letters, you need some sort of symbol like horseshoe, triple bar, wedge, or plus to explain the relationship. But if you begin to get a third relationship in there, like you begin to say, Tim is here, and Chloe is here, and Kirsten is here, and Jeff is here, and Sarah is here, you begin to get all these statements. At some point, you have something like J plus T plus L plus C plus K, and what happens is with plus and minus in mathematics, we can all remember that, you can just keep adding. You don't really have to have an order of operation. But if this was something like 2 plus 2 divided by 2, right, it makes a big difference if that is saying 2 plus 2 parentheses divided by 2, or if that's saying 2 plus 2 divided by 2 like this, right? Because this one is 4 divided by 2 equals 2, and 2 divided by 2 is 1, so 2 plus 1 is 3, right? And so it's very important to know where the parentheses go. And so the same thing is true. Anytime you have more than one operator, more than one symbol, you need to have parentheses so we know which ones go together and which ones don't. Okay? The symbols can go between parentheses and letters. They can go before parentheses. They can go between the letters in the parentheses. But this would be wrong to put it there because it's not there. And then once you get to that point, you also have to start adding in brackets, and you go on and so forth. And what happens is there should always be one symbol that would become what we call the main operator because it controls the most ideas within it. This controls everything in the parentheses, as does that. But this one controls the stuff inside both of those parentheses. And the brackets book all this together, making this the main operator. Does that make sense? Because in order of operation, you do these two, then you do the stuff in there, and then you would add these together in math as well as here. That becomes important more when we get into the next module than it does necessarily in this one. Now,